Okay, so welcome everyone and thank you for joining us today. This webinar is part of our ongoing XR5 pilot webinar series. And today's session focuses on remote inspection and maintenance of Industry 5.0 infrastructures. And I'm happy to let you know that we have experts from this field. So now I will leave the floor to Karim. Thank you.
Welcome everybody. My name is Karim Legeri. I'm CEO of Exo SRL, an Italian company participating to XR5, and we are a pilot leader of one of the pilots of the project. Together with us, we can go to the next slide. We are together with the Hololight responsible for the technical side, Innovax, Siemens, University of Piraeus, and Science, together joining the development of this use case, which is divided in three user experiences. I would like to give a short introduction to our activity. Clearly, the use case is strongly bound to our field of operations. We are the Italian leader of no-dig and trenchless services and techniques. This means that we operate in the maintenance of infrastructures with no-dig and trenchless technologies, trying to eliminate and reduce the general environmental impact, reducing overall digging trenches as for classic maintenance activities. We use composite materials, generally with thermosetting resins, and reducing very strongly all the maintenance operations. The pilot came out directly from the analysis of our experience and examining the value chain of our operation. We spotted out three moments, three activities that could strongly benefit with the experimental development of devices, solutions within XR5 project. The first use case, probably the most interesting, is directly linked to an infrastructure we have recently restructured and sensorized. This means that we have realized a potable water pipe, restore it completely via our techniques, and installed a chain of sensors that are able to locate and signal any kind of anomaly within the pipe and give the indication and the location of this anomaly. The idea behind this first use case is to give and develop an instrument to the maintenance operator to very quickly individuate via a simple geolocalization or a map on a portable device, and clearly intervene directly on the right place where the anomaly is detected, typically a leakage. The second use case is bound to another typical activity of our operations, namely the video inspection of the infrastructure, which is a preliminary and final strategic operation we carry out via CCTV robots remotely controlled by a human operator. And this activity is very important for a preliminary analysis of the situation and for the analysis, for the final examination of the work carried out. in this sense, the AI support we have thought and we have developed is a full support through AI for the analysis of the anomalies within the pipe. Generally and typically human activity carried out via a visual examination of the CCTV produced that should be supported or eventually fully made autonomous via AI processing and elaboration. The third and final use case is probably a more ordinary solution, but strongly that could give a strong support in terms of efficiency and effectiveness of these activities, is a development of an AR training and operation support device that could give online or offline a strong support during training, so typically a desktop activity, or during the operations, so giving full support to the operators in terms of necessity of consulting or consultancy for the operations. These three use cases are, as I already said, strongly bound to the necessities felt by the operators on field, and we are convinced that they could bring great development in terms of efficiency and effectiveness for bolstering our activity within this. And first results and experiments on the solution developed have been successful in giving strong answers to the operators themselves. Thank you.
Okay, so hi everyone. So I will now talk on behalf of science. So I'm Sofia. I will be presenting on behalf of Andreas, who has been working from our side on the project, but he couldn't be here today. I'm not sure if you can see me. It seems that my camera is not working, but I hope you can at least hear me. Can you hear me?
Sophia. We can hear you, yes.
Cool. Yeah, I'm not sure why my camera isn't working, but anyway, so now it is. So from our side, I will speak about developing an augmented reality system for sort of smart pipe inspection. And within this project, we worked with EXO to develop a solution that would visualize the information they get from the sensors of the pipes, and also to sort of show where leakages might be, as well as integrating different types of AI components coming from other partners, which they will be speaking about in a bit. The key challenge we had to address was to find a way to basically display information visually in a way that would be useful for the operators. In the initial implementation, we worked with a Magic Leap prototype. So Magic Leap is like a headset, an augmented reality headset. Within the app developed, we included sort of sensor information, anomaly displays, also the CCTV predictions and the chatbot. And the interface was quite sort of basic and hard to use. And after we had a feedback session with Karim from EXO, we decided to move to a mobile version, which is what we are working on now. So I will just tell you a bit about, sorry, the slides are changing. After the first version of the augmented reality app was developed, and we had the feedback, we realized that there was a lot of information that was needed from like the side of the developers, but it was not needed from the side of the operators. Also, having magic leap and deploying a technology like that in the field would be dangerous for the workers. So it was important to go to a solution that would be safer. We had at the beginning a way where you would see like a point within the app where leakage where the sensor that was showing leakage might be, but it was important to show like between which two sensors the leakage might be. And also after we decided to sort of so this is a bit how the application looks now. For some reason, I could not attach videos on the slides. That's why you have pictures. But now we have a mobile interface where the operator can click on and have a menu with simple options on sort of choosing which sensor data to use. Also looking at the leakage. Now within the app, which also uses geolocated data, the operator can see where the leakage is, and so on. And then one thing from our side that we realized was working more closely with EXO helped us also make an app that was more useful, and also integrating all the other components from the partners in a way that could be used from the operators. Now the next steps that we are working on is implementing the training platform part. So that's from us.
Great, thank you, Sophia. Now we can move forward to the next chapter.
Hello everyone. This is George Fatouros from Innovax. We have developed the LLM search engine of the XR platform. Elena, can you? Yes. So the idea, the problem that we solve with this solution is that we leverage the technologies of generative AI in order to provide easy access and direct access to the knowledge and documentation for specifically to EXO and other industrial use cases, leveraging the reasoning capabilities of LLMs, the customization provided by these technologies, but also overcoming their shortcomings related to hallucination or knowledge cut off outside of their training set. For example, proprietary documentation, technical manuals, and so on. So what we built is, if you go to the next slide, is use case agnostic and domain agnostic service where the user can easily upload their documents, define with a simple text the instructions, what they want to achieve, how the assistant should respond, which is also optional, and based on them we can offer the service offers accurate responses that can adapt to the user needs, leveraging different decision agent that finds the relevant information from our knowledge base. We can respond also in multimodal fashion. Besides text, we retrieve also images or tables from the documents provided. Yes, and based on our evaluation, we have achieved very low hallucination rate and high faithfulness and accuracy in the responses. We have a specific pipeline in order to indexing and storing the provided documents through an OCR approach where we, in the previous slide, where we indexing all this information. So besides documents, we're analyzing the images and all the different artifacts in the documentation in order to provide accurate retrieval of this data. And now, in the next slide, as I said, we can support different use cases. In our project, already 3 industrial partners, including EXO, have integrated with our component, and it is a service where you can programmatically, through a REST interface, you can inject your data, your documentation, and then retrieve it. And this is how we do it with EXO. So the XR application, analyzed by Sophia, retrieves in real time, based on user queries, information from our infrastructure, from the LLM chat engines, and provide assistance to the user. Notably, for example, the space pilot related to edge device assembly training have integrated and used the platform without any help. So, I mean, it's very easy to use it. And now in the next slide, if you let me share my screen, I can give you a very quick demo. Okay. Okay, I guess you can see my screen. So we have, besides the API, we have built a simple user interface. So here you can see in the knowledge base, you can see the documents already indexed by Exopilot. And you can see here the relevant metadata and the summary of its document. Regarding the agent customization, here the user can adapt the instructions to the agent how he wants to reply, if we want to include citations, the format, and so on. And we also have here a live chat interface, which it's identically, it talks to the same API as that the XR device make request. For example, I can ask which talks. I am the admin, so I have access to all the pilots. So here you can see that we have these documents from EXO, and I can make, for example, questions about and now we have implemented different approaches to have accurate retrieval, like metadata filtering, besides just simple retrieval event generation. You can see here the steps and also the references and the actual or the original PDFs where the information is there, and also the specific images relevant to the response. All this information is also provided to the XR device. And this concludes this demo. So back to you, Elena.
Thank you, George. That was fascinating. So we can move forward. Sophia, I think you should, yeah. So now we can move forward to the next chapter. So Sterios, I suppose it's your turn.
Yes, hello everyone. I'm Sterios from UPRC, and along with Dimitris, we worked on a use case two that Karim mentioned before. We developed a solution for CCTV inspection. So what EXO currently does in a CCTV inspection is that there is a human operator which goes through a whole video of pipe inspection, and he notes down the various outliers, defects he can identify in the pipe. So what we wanted to do is to create a model that it's not a traditional AI model that's black box and it just outputs the outlier without any context. We developed a model that is able to, that's transparent, and it's able to predict these outliers using some concepts on the images, the videos that it sees. And along with this model, we also have implemented an active learning module, which allows us, because there is a lack of big data sets for these outliers in pipe inspection scenario. This active learning module allows us to have the human in the loop and get the expert feedback on models prediction, so as to be able to improve the model's prediction and to train them without the need of a lot of data. So in the next slide, we can see the overview of the system architecture. Our solution is running right now through Science mobile app, and what is doing is that the CCTV inspector can upload the video in the app. The model frames the video and outlines the outliers of the pipe inspection, which are then presented in the mobile app. You will see later a screen. And there is also the active learning feedback, as we mentioned before, where the CCTV inspector, the expert for us, can approve that this is indeed an outlier or change the model's prediction. For example, it may be, the model may predict a crack, but it can actually be a corrosion or a normal frame that the model hasn't identified. It can be corrected by the CCTV inspector. In the next slide, you can see an image from the app where both the prediction of a frame and the concepts based on which the prediction is based on are presented to the user. So the model shows why it has predicted this frame, this specific frame of the video as normal. These concepts are predefined. We define them before the start of the training of the model, and the model is able to recognize most of these concepts on each video, each frame it sees, and it ends on a prediction based on these concepts and not as a single black box. And all this is to make the human inspector more confident in what the model outputs. Next slide. Here we can see the active learning feedback with UI we have developed, where the human inspector can also see the model's prediction. For example, this is predicted as leakage with confidence at 30%, but the human inspector can intervene and he can label the frame as crack, which is more suitable to this image. And this allows us, as I said before, to retrain our models and with a better data set and have better predictions, have our model have better predictions. So what we managed for the pilot through our solution is to create a concept bottleneck model, which is an explainable AI model by definition and not a black box. We have also implemented the active learning framework, which maintains the human in the loop and thus allows us to have the expert feedback to improve the model and to train it without the need of huge data sets. And all this enhances the human cognition and allows the inspectors to trust the model's predictions more because they see the reasoning behind these predictions and not just that this video may have a crack or may have a leakage, but they can see why the model believes that in this frame there is a crack or there is a leakage. So that's all from our side.
Hello, this is Robert. I'm an R&D software developer from Zimos, and our role within the XR project for the Exopilot was to support and enable the use case development within the pilots. So in this case, we developed solutions that help the navigation within the AR application and data consumption. One such example is the Smart Pipes application, which ingests basically, such as an ETL pipeline, ingests data sets and provides web server access for the AR application, which was built by Andreas. Okay, can we go to the next slide? Okay, some key capabilities of our Smart Pipes application are represented by the anomaly geolocation, which pinpoints the issue where a certain anomaly can be found based on the distance provided through the inspection. We have a scalable time series storage, which is very good for integrating edge devices such as VR sets, headsets, or Android devices for streaming the data, while also providing basic time series operations for reducing or changing the aggregation for enabling easier and more streamlined visualizations. We have an open integration to our API interface. We have the operational reliability, which is represented by the ETL pipeline, so importing, query caching, and health monitoring, which are built in directly in the REST API. And as I said, this is ready for deployment since our services come containerized, so they can be moved for any kind of hardware infrastructure. Okay, next slide. Here we have a high-level architecture showing how our service is connected with the real world. In the left side, we have the information coming from the physical infrastructure and also the historical CSV datasets. that we ingest through the ETL pipelines. We store them through a time series database, in this case timescale.db. We compute anomaly geolocation through geolocation coordination computing algorithm, and we provide all of this in a streaming package for the AR application to consume in real time for displaying this information directly to the end user. Okay, this was all from my side. Thank you.
Thank you, Robert. So now we can move forward to the live audience survey. I will share my screen. Great. So I would like now to grab your phone and scan this QR code. Great. I will wait for a couple of minutes. Great. Just to be sure that every of you has scanned the QR code. Okay, yes, let's go to the first question. So when you imagine seeing underground infrastructure through a smartphone or headset, what is the first word or phrase that comes to mind? Great. So once you write your answer, you should also press the button submit. Great. Okay, I will wait a bit more. So innovation, interesting, AR video, wow, amazing. Innovation, interesting, helpful. I think I need 2 more answers. Okay, okay. So I will move forward to the next slide. So how do field operators in your sector or organization currently access visual information about underground or hidden infrastructure on site? Once you choose your answer, you also press the button submit. Great. Okay. Perfect. I will go to the next slide. So if you were a field operator using an AR application on site, rank these data types from most to least important to see overlaid on your real-world view. Let's see your answers here. Great. Okay, I will wait a bit more. Great. Okay. So I will move forward now. Okay. Great. So, if an AI system flagged a potential pipe defect in inspection footage, what would most increase your trust in that finding? Again, you choose your answer and then you press the button Submit. Okay. So I will move forward to the next slide. Okay. How important a role do you think digital tools such as AR overlays and AI alerts could play in improving safety for field workers in infrastructure? Great. Nice. Okay, significant role. I will wait for a little bit more. Great. Okay, I will go to the next slide now. And this is the last one. So what would need to be true for your organization to seriously consider deploying AR and AI tools for infrastructure inspection and maintenance? Let's see your answers here. Great. Okay. Great. So that was the live survey. If you have any kind of question or if you want to discuss anything, please feel free to ask our experts. Or also you can write a question on the chat. Okay, so if you don't have any questions, I would like to thank all the speakers for the great presentation and the insightful insights shared with us. The webinar recording and the presentation will be online on our website. So yeah, thank you all and have a great day.
Thank you.
Thank you.
Bye.
Bye.
Thank
Thank
you.
you. Bye.
Bye.
Thank you.